good afternoon, or good morning, whatever time it is. We're back in AP Maths, and we are finally starting our work on function, which is part of our calculus. Okay, so we're really doing calculus now. After saying that, the first lesson, we're going to have two lessons. The first lesson is, I'm not really going to say anything new. It's just really to make sure we're on the same page. But already the second lesson this week, we'll learn something new. So, functions, okay? What is a function? I mean, you guys got used to having like f of x equal x squared plus 1, or y equal 2x minus 1, or sometimes you just draw a graph, right? You've got the x-axis, y-axis, graph, okay? But what really is a function? If you take maths further into university, it will be very different to high school, and you'll have to think about things with more in depth. So a function really is a mapping, okay? A mapping. It's a way, it's like a set of rules, that maps points in a certain set onto another set of points. Okay, what does that mean? Imagine we have set A, we call it set A. It's a bunch of numbers. 1, 5, 7, 8, 2 over 15, okay? Or it could be all the numbers, all the real numbers, okay? Or all the integers. It's a set of numbers. Now you've got another set, we'll call it set B. Okay? It could be the same numbers, it could be other numbers, okay? A function is a way of mapping each point in set A onto point in set B. And there's one rule that a function for this mapping that we can call it a function. There's one rule. The rule is that each point here in set A must go onto only one point in B. We cannot have a situation where, let's say, this point here, okay, can be mapped onto a point here and at the same time to another point there. That obviously is not a function. And we're going to look at some examples that are not function in a minute. Okay? So that is not possible. However, the opposite is possible. What is the opposite? There could be a situation we have 2 points in set A that are mapped onto one point B. And again, we're going to look at these examples. You know them. Now, in this language, the set A, okay, I'm sure you've heard of that word before. It's called the domain. It's all the values of x that can be used in the function. And all points in set B are called the range, okay? What f of x can be equal to. All the values of f of x can be equal to. Okay, so not much new, maybe except for that word map. Okay? Let's look at some more examples now. Okay, so let's look at some graphs and decide together whether they are a function or not. Okay? So we'll start with a simple linear graph. Okay? The question we're going to ask ourselves to find out if it's a function or not, is each x here, each value of x, is it assigned to one value of y? And the way to get that is to say, okay, let's just choose this x. How do I know what's the y value assigned to it? We're just going to go up vertically until we meet the graph, and then we're going to turn 90 degrees, and we'll find the value of y. So for each x here, if I cross this graph with these vertical lines, I'm only going to assign one value of y. So it's definitely a function. Okay? Moving on to the parabola. Okay, so I'm going to pick up a certain x, let's say here, right? I'm going to go down until I meet the graph, and then I'm going to turn left 90 degrees, and I'm assigned one value. So it is a function. But it's slightly different to this one, because what we notice here, that there are actually two x's that are assigned the same y. Is that a function? Yes, it's still a function. We can have two x's, two in the set of what do we call the domain that are assigned the same y. That is a function. The opposite we can't have, okay? So let's move on to this. This is a circle, okay? But actually we can give a mathematical relationship to that circle. You probably know it. We'll go over it in a bit. Okay? Is that a function? Well, let's pick up an x and let's go to the graph, find the y. Now, I can either go up, in which case I'm going to get a certain y here, but I can also go down and meet the same graph and get a different y. So 1x will have 2 y's. That obviously is not a function. Okay? That's a function, that is not a function. Okay? However, not everything is lost. If I just take a half, the upper part of that circle, you see I ignore that one, okay, we'll see how we can do it in a minute, then obviously that is a function. Okay? For each x there's only one y. Okay? For each y there's 2x, but like we said, that's okay with the function. Okay? And if we take the lower part of that semicircle, the lower part of the circle, it's the same thing. We're going to have a function as well. What about if we take just like the left part of that circle? Let's say something like this. Okay? Is that going to be a function? Well, let's choose an x. Well, if I choose this x, I'm going to have 2 y's. So that is not a function. Okay? Right. That's it. Let's move on to the next part of the lesson. Okay, chaps. So one more mathematical relationship that I want to discuss is this vertical line. Is a vertical line a function? Okay? So the answer is no, obviously. Okay? So the mathematical relation will be x equals 3. So when it's x3, you've got to ask yourself what y is assigned to it. And it's actually all the y's there is. Y equals 1, y equals 2, y equals 0, y equals minus 5. They're all there. So we've got one value of x assigned to all the y's in the world. So obviously that is not a mathematical relationship. Okay, where are we going now? It's just going to go through all the curves that we know how to deal with and just try and describe them mathematically. So the first one, let's start on this side, is a horizontal line. Okay, you've seen, I'm sure you know, that's just y equals c, where c is some kind of constant. Okay. Next one, a linear line, so we've got a little slope now. Okay, that's going to be y equal mx plus n, right? Where m is the gradient, okay, or the gradient, you know what gradient is, and n is the y-intercept. Okay. Next one, we've got this parabola. Okay, and by the way, I'm going through pages 59 to 61, and or up to 62. So I recommend you having that page 59 to 62 because I'm not gonna go through all these functions. I would recommend you having a look at it, so it will be just to make sure you cover everything. I'll go through the main ones, almost all of them. So the next one are these parabolas. Okay. Now this is a parabola that is centered around the x-axis. So it's relatively an easy one. So it's y equal ax squared plus a b, we'll call it. Okay, so we don't have a bx. We don't have something with an x next to it. So the y is centered around the y-axis. Obviously, if a is positive, then it will be a smiley face. Now here it looks like a is negative. Okay. The b, it's just a vertical shift. Okay? If I wanted to move it to, okay, we'll go through that. I see they did it later, so I'll do that later as well. Now, these ones, we had a look at them early in the year, if I'm not mistaken. They are exponents. Okay? So they are all on y equal a to the power of x. When a is larger than 1, okay, it's an exponential increase. Okay? So, coronavirus, okay, when that goes up. In other words, I don't know if you've heard of that R value, okay, for corona, the R value, the number of people one person will infect in his time, okay. They usually talk about coronavirus have an R value of around 2, okay. That is actually our A, okay. That exactly is our A. The R value is the value here. When it's larger than 1, exponential increase. When a is smaller than 1, between 0 and 1, then it's going to go like that. Just going to check myself here that I'm not making the same. Yeah, between 0 and 1, it's going to be exponential decay. So us, by creating all these social distances and all these things and processes we put in place, we're trying to decrease that a, they call it R in coronavirus. So turn the up curve to a down curve, okay? Right, these guys, okay, I think we might have mentioned them sometime this year, but I'm sure you've done it in maths. They're called hyperbolas, okay? And they've got these asymptotes, okay? And we're going to write them as y equal a x minus p, okay? And I'm just making up some letters. I don't know, you might have used other letters. So x minus p. This p determines where you're going to have your y asymptote. When x equal to p, in this case, it blows to infinity. Okay? Plus or minus infinity. If you put x equal p, p minus p is 0, a divided by 0, it goes to infinity. Okay? If you go from the left, this is for a larger than 0. This graph is for a larger than 0. Yeah. So if x is larger than p, okay, it's going to be positive. But as x approaches p from the right, that means it's a little bit over p, but it's getting close, that is becoming smaller and smaller, positive number. So it approaches 0 from the right. Becomes 0.1, 0.01, 0.0001, becomes smaller, smaller, and smaller. In other words, this whole thing gets bigger and bigger and bigger, and that goes up like that. Okay, it goes to infinity. If you approach p from the left, so in other words, x minus p is, let's say, is minus 0.1, then minus 0.01, minus 0.0001, you're getting, again, a small number, but now negative. So negative, you're going to blow it up to minus infinity. Okay? So that's for a positive. The q, what does the q do? It just vertical shift. So up or down, depends on what the q is. If you're reversing the a, keep the same thing, the same function, but now you say a is negative, then it's just going to flip everything. So the positive will remain negative and negative will remain positive. I'm just going to stop here because I can see